Hey mathematicians, as you can see here, we are starting to venture into bigger numbers, and even though we've been using number lines and chips, I don't know about you, but you might not necessarily want to, let's say for example, drag 139 red chips into a model, right? So we're still going to use the ideas of modeling, but we're going to start trying to attack this from more of a place where we're not going to actually build the models, but still think about the idea while we're deciding how to attack the problem. So what I mean by that is I've got a negative 139, for example, right? So we know that that would mean that I would be putting 139 negative chips into the workspace if we were building a model. Plus, you can see that we're adding 46 negative chips as well. And we're putting that into the workspace too. So because they're both negative numbers, imagine, we would add like a pile of 139 negative chips here and a pile of 46 more negative chips here. So it's really just going to combine into one big pile of negatives, right? So we really just need to add those two numbers together. So I've just set it up as an addition problem because we're not using calculators. So 9 plus 6 is going to give me that 15, which I'm going to carry my 1. And then 3 plus 4 is 7, plus 1 is 8. Nothing to carry. We're just going to bring that 1 down because there's nothing to add it to either. So we've got 185. And then because it was a negative number being combined with another negative number, we basically, again, just have a big pile of negatives. So that would be a negative 185. So you're going to type into that answer box negative 185 into the first answer box. In problem number 2, I'm going to still approach it from the same idea. So rather than a negative number, this time I would be putting into the workspace, I'd be putting in a positive 12, but I would also be putting into that workspace a negative 59. So think about what would happen with when you have those chips. And actually, I'm going to make this pile kind of a little bigger to kind of visualize the fact that we've got 12 negatives in there, but we've got 12 positives in there, but we've got 59 negatives. Well, if this really were a big pile of chips, we would take the 12 positives and they would cancel out 12 of those negatives, right? And then what would be left over after doing all that canceling would be however many negatives are left over. So we know that our final sum is going to be a negative number because we've got more negatives than we do positives. And so to figure out how many you would have left over, we just need to subtract those two numbers. So 59 minus 12, so 9 minus 2 is 7, 5 minus 1 is 4. So after you cancel out 12 of those negatives, there would be 47 negatives left over. So we are going to type into our answer box negative 47. Alrighty, for our last example, again, let's think about what's happening here. So we're going to start off with negative 34. So that means we would put 34 negative chips into the workspace. And then we would combine that with 105 positive chips. So they're not the same sign. So we know that these 34 would cancel out 34 of that 105, right? So the final sum is going to be what's left over out of that 105 once you get done canceling these two sets out. So to figure out how many would be left over, once again, we're going to subtract. So 105 minus 34. So 5 minus 4 gives you 1. 10 minus 3 gives you 7. So you'd have 71 left over, and again, that's 71 positives. So here in the answer blank, you would just type 71.